Hello students, my name is Shridhar Reddy. I am your chemistry educator for grade 10. In this session, we are discussing chemical reactions and equations. So here, first of all, we will learn what is chemical reaction, and then we will be moving to chemical equations. How to write a chemical equation and then how to balance a chemical equation. We are not stopping with balancing chemical equation. We will be trying to make it more informative by mentioning heat changes involved in the chemical reaction and physical states of the reactants and products, and finally, if any conditions are required for the reaction, we will be mentioning these things and making it more informative. And then we will be moving to types of chemical reactions. Here we will be learning various types of chemical reactions such as combination reaction, decomposition reaction, displacement reaction, in fact single displacement and double displacement reaction, and then oxidation reduction reactions, neutralization reaction, right? And finally we will also be learning effects of oxidation reactions in everyday life. And not only these things, we will also be solving few questions while we are discussing the topics, right? So that will be making you more comfortable and more confident in solving any type of question of any level, such as board level or NTSE or Olympiad level. Hope you will like the session and you will be more confident by the end of this session, right? So starting with chemical reactions, right? So let us start with the chemical reaction. So we'll now try to understand what is a chemical reaction, right? Chemical reaction is a process in which one or more substances get converted into one or more new substances. Here, new substances are formed always. In a chemical reaction, new substance is always formed with new properties. Obviously, when it is a new substance, it is with a different composition. So obviously, we expect with new properties, right? See here, substance A reacting with substance B and giving a new substance. It is a new substance. New substance with new properties. It is because of the change in composition of the substance. Why does it have new properties? Because there is change in composition of the substance. It is neither A nor B. It is a new substance. So remember, chemical reaction means in any chemical reaction, new substance is always formed with new set of properties, right? I hope you understand what is chemical reaction, right? Now we will take a look at few examples from our day-to-day life, right? See, burning of wood, burning of coal, burning of fossil fuels. Okay, so here always a new substance is formed. Here carbon dioxide is liberated, which is a new substance, right? So it is a chemical change or chemical reaction, right? We'll take a look at more examples. Rusting of iron, new substance is formed. This brown colored substance formed on the surface of iron. This is a new substance. So what is this new substance? This is hydrated iron 3 oxide. So we started with iron. When it is left for atmospheric air, it reacts with oxygen and moisture in the air, and it will give a new substance called hydrated iron 3 oxide. So new substance is formed. So these are chemical reactions, right? And we'll take a look at one more interesting example. Photosynthesis is also a chemical change, because this plant takes light energy from sun. It takes light energy from sun, and it also takes carbon dioxide from atmosphere, and then it gives us oxygen. Not only oxygen, it gives us sugars, right? So new substances are formed. Oxygen and sugars, new substances are formed during photosynthesis. So this is also a chemical change, right? So how do you know whether a substance has undergone a chemical change or not? How to identify? Yes, there are some indications for chemical change. We will now take a look at these things one by one. Formation of precipitate. Formation of precipitate is one of the indication for a chemical change. Formation of this is a precipitate. This is precipitate. What is precipitate? Precipitate is nothing but an insoluble solid substance formed. Insoluble solid. An insoluble solid. The precipitate is nothing but insoluble solid substance. Right? So formation of precipitate is one of the indications for a chemical change. Like evolution of gas, you can see here bubbles of gas, you can see for release of gas. Release of gas. Right? If any substance undergoes some change and if you see evolution of gas from that substance, then you can say the substance has undergone chemical change. Another indication for chemical change. Right? We'll take a look at more indications. In fact, these are called characteristics of chemical change. Right? One of characteristics was formation of precipitate and then evolution of gas, and now change in color. Change in color. See, we have taken copper sulfate solution. Copper sulfate solution which is in blue color. Which is in blue color. And now what we do, we'll put an iron nail in it. See, iron nail which is in gray color. Right? Now after some time, after few hours, you will find change in color. Change in color in the solution, green color. Now what had happened here? Displacement took place. Displacement reaction take place and color of the nail and color of the solution has been changed. Change in color is also one of the characteristics of a chemical change. Right? And not only formation of precipitate, evolution of gas and change in color, okay, change in temperature is also one of the indication. Change in temperature. Change in temperature. Right? So, for example, if you take calcium oxide and add water in calcium oxide, which is quicklime, it is in fact slaking of lime. We are aware of it. Slaking of lime, here calcium hydroxide, a lot of heat is released. So what's happening? When water is added to quicklime, calcium hydroxide, and lots of heat is released, so that there is change in temperature is observed. Right? So change in temperature is also one of the characteristics of a chemical reaction or chemical change. Change in physical state. Change in physical state. It is also one of the characteristics of chemical change. Change in physical state. See, let's take water. We are sending electricity through water, in fact acidified water, so that it gets decomposed and give hydrogen gas and oxygen gas. So here we notice change in physical state. See, water is in liquid state, whereas the new substances formed are in gaseous states. So here we notice change in physical state of the substance. So what are the characteristics of chemical change? Formation of precipitate, evolution of gas, change in color, change in temperature, and change in physical state. So these are the indications for a chemical change. This is how we can find whether a substance has undergone chemical change or not. And to conclude, characteristics of chemical reaction, they are evolution of gas, formation of precipitate, change in color, change in temperature, and finally change in physical state of the substance. So now we are learning something very interesting. See, you might be wondering what exactly happens during a chemical reaction, right? So we will now try to understand what exactly happens during a chemical reaction, right? So it is basically rearrangement of atoms. During a chemical reaction, new atoms are not formed. Okay, the atoms simply, they get rearranged, right? So let us see what exactly happens step by step. See here, copper oxide reacting with hydrogen to form copper and water. See here, what do we notice here? See, copper oxide, there is a bond between copper and oxygen, right? So first of all, these bonds will break down. The existing bonds will break down. So the first thing is breaking of bonds. Breaking of existing bonds, existing chemical bonds. And then these atoms can go and get rearranged, right? So now oxygen can now go and combine with other atoms like hydrogen. See, you can see here oxygen is forming bond with hydrogen atoms, right? So second thing is rearrangement of atoms. And finally, we can notice formation of new bond. Formation of new bond between hydrogen and oxygen. Formation of new bond. Right? So basically, atoms get rearranged. Existing bonds will break down and then rearrangement takes place and finally formation of new bond. This is what exactly happens during a chemical reaction. Right? Now we will take a look at chemical equations. Right? Chemical reaction done. What is chemical reaction? Characteristics of chemical reaction and what happens during a chemical reaction we have seen so far. Right? Now we will be moving to chemical equations. So here we will learn what is chemical equation and how to write a chemical equation and how to balance a chemical equation and how to make it more informative, right? And types of chemical reactions finally. Right. Now, chemical equation. What is chemical equation? It is a method of representing chemical reaction using symbol and formula of the substances involved in the reaction. Right. So, we'll take an example and we will write a chemical equation for the given chemical reaction. What is the chemical reaction that we are considering? Burning of carbon. This is a chemical reaction. Chemical reaction. Now we are trying to represent this chemical reaction using symbol and formula so that we will be having a chemical equation. But first of all, we will start with the word equation. We are simply writing names of the substances involved in the reaction so that we will get a word equation. Right? Carbon reacting with oxygen forming carbon dioxide. We are simply writing the names. We are simply mentioning the names. And then finally we are writing chemical equation. How do we write chemical equation? Using symbol and formula. Using symbol and formula of the substances involved in the reaction. So one of the substances involved in the reaction is carbon. We are writing the symbol. See, we are writing symbol. Oxygen formula O2 we are writing. Carbon dioxide formula we are writing CO2 so that we have a chemical equation with us. What is chemical equation? A representation of chemical reaction using symbol and formula. Very simple. Okay, we will take another chemical reaction and try to write word equation and chemical equation for the given chemical reaction. Right. The reaction we are considering is reaction of hydrogen with oxygen to form water. Now we will write word equation first and then chemical equation. How do you write word equation? Simple. Hydrogen reacting with oxygen, that means plus oxygen gives water. In words we are writing so that we will be having a word equation, right? So hydrogen, I'm writing word equation. Hydrogen plus it is reacting with oxygen and to give water is the new substance formed. So chemical reaction in the form of word equation. And now I'm converting it into chemical equation using symbol and formula. Hydrogen symbol, we don't write H because hydrogen is the element which is existed in the form of molecule in the nature. So I write H2 in the form of molecule. Okay, in the same way oxygen as well. O2, we write O2. And then water molecular formula H2O. So this is chemical equation. Right. We have now learnt how to write a chemical equation. Right. We will now move forward and learn essentials of chemical equation. What should be there in any chemical equation. Unless we mention few things, it is not a chemical equation. So what are those things? We will now take a look at them one by one. Okay, essentials of chemical equation. The first thing is, a chemical equation must represent a true chemical change. A chemical equation must represent a true chemical change. That is the first thing. Okay, see, let's take an example. Reaction of zinc with hydrochloric acid to give zinc chloride and hydrogen gas. Does it represent a true chemical change or not? We have to check. Yes, see, zinc is more reactive than hydrogen. We need to refer to activity series of metals, right? Zinc is more reactive, so that the zinc can replace hydrogen from hydrochloric acid, and so that it can give hydrogen gas and zinc chloride is formed. Yes, it is representing a true chemical change. But if you take a look at the other reaction, other equation, if you take a look at this equation, see, platinum is least reactive. It is least reactive, so that it cannot displace hydrogen. It cannot displace hydrogen from hydrochloric acid, so that it cannot give hydrogen. So this reaction is not possible. So this equation is not representing a true chemical reaction or true chemical change. So this is not a chemical, we don't consider it as a chemical equation, but this is a chemical equation because it is representing a true chemical change or true chemical reaction. Right, we will now take a look at one more essential of chemical equation. A chemical equation should be molecular. So what do you mean by molecular? There are few elements like hydrogen, oxygen, nitrogen, and halogens like fluorine, chlorine, bromine, and iodine. When these elements are involved in any chemical reaction, these elements should be represented in the form of molecule, but not in the form of atoms. Okay, let's take a look at one example so that you understand it better. Here, reaction of nitrogen with hydrogen to form ammonia. Right? So here you cannot write it like this. Nitrogen reacting with hydrogen to give ammonia. You can't write like this because this is not in molecular form. This equation is not a molecular equation. This is atomic equation. So we should write this equation like this. Now this is representing a true chemical change and it is in molecular form. So this is a chemical equation. Right? It is representing a true chemical change and it is in molecular form. So it is a chemical equation. There is one more important thing that we should know is a chemical equation should be balanced. Okay, unless the given chemical equation is balanced, it is not considered as a complete chemical equation. Right, we'll take an example. See, let us check whether it is balanced or not. Is this equation balanced? See, let us see. One iron atom on left hand side, but whereas on right hand side of the equation we have 3 iron atoms. It is not a balanced equation, but a chemical equation should always be balanced. Right? So you might be wondering how to balance a chemical equation and what is balancing. What do you mean by balancing and how to balance a chemical equation? Right? Now we will learn how to balance a given chemical equation. So we are now learning balancing of chemical equations. What is a balanced chemical equation? How to balance a chemical equation we are learning. First of all, we need to understand what do you mean by balancing a chemical equation. Right? It is very simple. The process of making a number of atoms of different elements equal on both sides of the given chemical equation. Right? See, here, let us say these are the reactants and these are the products. Okay, so we need to make sure number of atoms of different elements are equal on both sides of the equation. Before we practice balancing chemical equation, we will understand why to balance a given chemical equation. What is the need of balancing a given chemical equation, right? It is because of law of conservation of mass. To satisfy law of conservation of mass, we are balancing any chemical equation. According to law of conservation of mass, the total mass of the reactants should be equal to the total mass of the products. Or in other words, we can say matter can neither be created nor be destroyed in any chemical reaction. So in order to satisfy law of conservation of mass, we are balancing any chemical equation. What is balancing? Balancing is nothing but making sure the number of atoms of different elements are equal on both sides of the equation. So how to balance? Using hit and trial method, right? See, example, hydrogen bonds in oxygen to form water, right? So first of all, we write this is a chemical reaction. This is chemical reaction, and first of all we are writing word equation, names of the substances we are writing, hydrogen burning in presence of oxygen to give water, word equation, and then we are writing finally chemical equation using symbol and formula. So chemical equation, we have chemical equation, but here what are we learning? To balance this chemical equation, we need to make sure number of atoms of hydrogen and oxygen are equal on both sides of the equation, right? Let us do that now. So here we need to count the number of atoms of hydrogen and oxygen on left hand side and right hand side so that we can balance this chemical equation, right? Here reactant side and product side, okay? So number of hydrogen atoms and number of oxygen atoms. Reactant side number of hydrogen atoms, 2 hydrogen atoms, and product side also 2. Number of hydrogen atoms are okay, they are balanced. Number of oxygen atoms, 2 on left side and only 1 on right hand side. So we need to make sure number of oxygen atoms are equal on both sides of the equation. So how do you do that? We cannot put 2 over here. It will change the composition of the substance. So we can never do this. Now what we can do is take a suitable coefficient and multiply whole substance with a suitable coefficient, a least possible number, right? So we need 2 oxygen atoms on right hand side. So what I will do is I will multiply water with a coefficient called 2, so that now I have 2 oxygen atoms on right hand side. But there is again change in number of hydrogen atoms. Please notice, number of hydrogen atoms on right hand side are now 4. It is not 2. Now our job is to make a number of hydrogen atoms on left hand side. It should be 4. So I multiply hydrogen with 2, so that we now have number of hydrogen atoms 4 on left hand side. Now check, number of hydrogen atoms and number of oxygen atoms are equal on both sides of the equation. Now this is how we balance any given chemical equation using hit and trial method. Okay, we'll take more practice so that you will be comfortable in balancing chemical equations, right? See, we will consider one more chemical reaction, and we will write word equation and chemical equation, and then we will balance it, right? So the reaction we are considering is methane bonds with oxygen to form carbon dioxide and water. So what are the reactants in this chemical reaction? Methane and oxygen are reactants, and products carbon dioxide and water are the products, new substances formed, right? And now chemical equation we are writing. How to write chemical equation? We are simply mentioning the formulas of the substances, formulas or symbols. Methane we are writing formula, CH4, oxygen we are writing formula, and then carbon dioxide formula and water formula we are writing, so that we have a chemical equation. But now our job is to balance this equation. We will now try and balance it. Yes, in order to balance, what do? We will count number of atoms of each element on left hand side and right hand side. Yes. Number of carbon atoms on left hand side 1, right hand side 1. Okay. Number of hydrogen atoms 4 on left hand side, whereas we have 2 hydrogen atoms on right hand side, so we need to make it 4. How do you make it? Multiply H2O with 2, so that we have now 4 hydrogen atoms on right hand side as well. Right, now let's take a look at number of oxygen atoms now. Oxygen atoms 2 on left hand side, but whereas 4 on right hand side. 2 here with carbon dioxide and 2 with water. Total 4 oxygen atoms. So we need to make it 4. How do you make it 4? Without changing the composition? Coefficient 2. Now we have 4 oxygen atoms. Hope it is now balanced. Right? See, carbon atoms 1 and 1. Number of oxygen atoms 4 oxygen atoms on left hand side and 4 on right hand side. Hydrogen atoms 4 hydrogen atoms on left hand side and 4 on right hand side. It's balanced. We are not stopping with balancing a chemical equation. We can make it more informative. How to make a balanced given chemical equation more informative we will see. Right? So there are 3 ways in fact. Okay, by mentioning physical states of the substances, and by indicating heat changes involved in the reaction, and finally conditions required for the reaction, and if any catalyst is required, mention the symbol or formula of the catalyst. Right, we'll take a look at them one by one. Right, so the first thing is it can be made in 3 ways. First thing is mentioning physical states of the reactants and products in a given chemical equation, so that we can make it more informative. Indicating physical states, whether the substance is in solid state, liquid state or gaseous state, or it is aqueous solution. Right, we will take a look at that. And the second one is by indicating heat changes, change in heat during the reaction, whether the reaction requires heat or it releases heat during the reaction. Right, see, finally conditions, the conditions under which the reaction takes place. What do you mean by conditions? Temperature and pressure conditions. Right, and if any catalyst is required, so that we can make the given chemical equation more informative. See, we will discuss them one by one. Physical states. If a substance is in solid state at room temperature, we write S in the bracket. If the substance is in liquid state, L. If the substance is in gaseous state, G. If the substance is an aqueous solution, then we write AQ in the bracket. Right? So what is aqueous solution? Solution made with water. Solution made with water. Aqueous solution. Okay, we will take an example. See, if you take a look at this equation, this is not very much informative, because we don't know the physical states of the substances here. There is no clue about physical states of the substances. We don't know whether this is in its solid state, liquid state or gaseous state. Right? But whereas if you take a look at this chemical equation, physical states are mentioned. Calcium hydroxide is an aqueous solution. Carbon dioxide we are taking is in its gaseous state. And calcium carbonate formed is, it is precipitated, which is in solid state. And then water, liquid state. So this is more informative. This is more informative. This is more informative because we are writing physical states of the substances, state symbols. We are mentioning state symbols of the substances in the equation, so that it is more informative. Right. Now we will take a look at heat changes. So there are 2 types of reactions based on heat changes taking place in the reaction: exothermic reactions and endothermic reactions. If the reaction takes heat energy, then it is endothermic. If the reaction releases energy, then we call it exothermic reaction. Right? So how do we indicate exothermic and endothermic reactions? That we need to learn. See, we'll take an example here. This is an exothermic reaction. Burning of carbon is exothermic reaction because heat energy is released. Heat energy is released, so it is exothermic. But how do we indicate? We are writing plus heat on the right hand side of the equation. That is how we indicate release of heat, exothermic reactions. Right? You can either write heat or heat energy. Right? Next, endothermic reactions. Moving to endothermic reactions. So here, heat plus heat is written on left hand side of the equation. So that is how we indicate endothermic reactions. See here, heat is written plus the substance plus heat. It is written on the left hand side of the equation. Right? And one more interesting thing is most decomposition reactions are endothermic reactions. For the decomposition of substance, energy is required. So it always takes energy. So that it is generally endothermic reaction. Okay? Most decomposition reactions are endothermic reactions. Now, by indicating conditions under which the reaction takes place. Right? So what conditions are required for the reaction? We can mention them in the equation so that the equation is more informative. If the reaction requires heat energy, then we write delta either above the arrow or below the arrow in the equation. And catalyst, we write symbol or formula of the catalyst either above the arrow or below the arrow in the equation. And conditions of temperature and pressure, we write the values of temperature and pressure either above the arrow or below the arrow. Okay, we will take a look at examples so that you understand it better. It will be more clear to you. Right, decomposition of potassium chlorate, it requires heat energy. So we are mentioning delta above the arrow. It also requires a catalyst, manganese dioxide. So we are writing formula of catalyst. We are writing the formula of catalyst below the arrow. Right? If you take a look at this equation, Haber's process, manufacturing of ammonia in Haber's process. Iron is a catalyst. We are writing the symbol of catalyst. And we are also mentioning pressure conditions and temperature conditions. Right? So looking at this thing, you will come to know what are the physical states of the substances, and if any catalyst is required, and what temperature is required for the reaction to progress, and what pressure is required for manufacturing ammonia. This is how we can make given chemical equation more informative. How do we make it more informative? Mentioning physical states, and heat changes, and finally conditions required for the reaction, so that it looks more informative. Don't you think it looks more informative? Yes, it is. Right? So, moving forward and learning now types of chemical reactions. We know what is a chemical reaction, and we have learnt what is chemical equation and how to balance a chemical equation. Right? Now, we are looking at types of chemical reactions, starting with combination reactions. So, what is a combination reaction? Reactions in which one or more substances combine to form single new substance, which is called combination reaction. See, substance A reacting with substance B to give a single substance, single new substance product, single product. Here we get single product. Very important to remember. In combination reactions, we get single substance. Combination reactions are also called as synthesis reactions because a new substance is synthesized in the reaction. Right? So here a single substance is formed in combination reactions. We will take a look at examples. See here, magnesium reacting with oxygen to give magnesium oxide. a single substance is formed, combination. One or more substances combine to give single substance, combination reaction. Here, sulfur dioxide reacting with oxygen to give sulfur trioxide, a single substance, combination reaction. Calcium oxide and carbon dioxide combining together and giving a single substance, so combination reaction. But see, combination reaction is possible with various combinations. Like see, element and element, combination of elements here, combination of an element and a compound, combination of compounds, two compounds, see, combination of two or more compounds, calcium oxide and carbon dioxide. So in all the cases, a new substance, single new substance is formed. So these are combination reactions, right? Moving forward and learning more about combination reactions. Most combination reactions are exothermic in nature. During the combination, heat energy is released, right? We'll try to understand this thing in detail now. Let's see here, let us say these are atoms. These are atoms, atom. Okay, so what is happening? The bond is formed between these atoms so that a molecule is formed. Atom and atom, bond is formed between these atoms so that a new molecule is formed. But during the formation of new bond, energy is released, heat energy is released, so that combination reactions are exothermic. Okay? Yes, now we are moving to decomposition reactions. First of all, what is a decomposition reaction? Simple, a reaction in which a compound breaks down into two or more simpler substances. But here we will require some form of energy here, either in the form of heat or light or electricity to decompose the substance, right? First of all, let's take a look at general equation for decomposition reaction. See, a compound breaks down into two or more simpler substances. Here we will require some form of energy to break the compound so that we will get simpler substances, right? One more interesting thing is most decomposition reactions are endothermic reactions. We are using some form of energy here. Energy is used. Energy is used here to decompose the substance to get two or more simpler substances. This is decomposition reaction. So based on the type of energy we use, we have got different types of decomposition reactions. We will now see them one by one. Right, starting with thermal decomposition. So here heat energy is used. Energy in the form of heat is used to decompose the substance here, right? Heat energy is used to decompose the compound. See, we have few examples here, very important examples. Decomposition of calcium carbonate. When heat is required to decompose the substance, we indicate with delta, right? So calcium carbonate is decomposed into calcium oxide and carbon dioxide. How? Heat energy is provided. Heat energy is provided so that it gets decomposed and we get two new substances. In the same way, if you take a look at iron sulfate get decomposed on heating, and then we get iron oxide, sulfur dioxide and sulfur trioxide, two or more substances, right? And then lead nitrate, very important, decomposition of lead nitrate. What are the substances produced on decomposition of lead nitrate? Lead oxide, nitrogen dioxide and oxygen. Nitrogen dioxide vapors are found, brown vapors, and lead oxide in yellow color. Very important to remember. Yellow color, lead oxide yellow color, nitrogen dioxide, brown color vapors are formed, and oxygen gas is formed on decomposition of lead nitrate. In all these cases, heat energy is used. Heat energy is used. So that's the reason we name it thermal decomposition. These are all thermal decomposition reactions. And then moving to other type of decomposition reaction, electrolytic decomposition. So here, what kind of energy is used for the decomposition of a substance, right? Electrolytic decomposition, here we use electricity. Electric current is used to decompose the substance, right? We will take a look at one example here. Electric current is used. Right? We'll take a look at few examples. Water is taken. In fact, acidified water is taken and electric current is passed through water, and then decomposition take place. Hydrogen gas and oxygen gas are produced. Right? And then in a similar manner, we take molten sodium chloride, molten sodium which is in liquid form, molten sodium chloride, and then we are passing electricity through molten sodium chloride so that decomposition takes place and we get sodium and chlorine, right? So this is electrolytic decomposition. Electricity is used here. Energy in the form of electric current is used for the decomposition of substance, and we name it electrolytic decomposition. And then we are moving to other type of decomposition reaction, which is photochemical decomposition reactions. So here, what is the energy that we use? What kind of energy we are using here? Here we use light energy. Light energy is used here for the decomposition of a substance. See, light energy is used, right? Some examples. We will take a look at few important examples here. Silver chloride, which is in white color, it gets decomposed when exposed to light and then gives silver and chlorine. And silver bromide is in similar manner. When silver bromide is exposed to light, then it gets decomposed into silver and bromine vapors are formed. So here light energy is used. So we call it photochemical decomposition reactions. So what are the various types of decomposition reactions that we have seen so far? Thermal decomposition where heat energy is used, and then electrolytic decomposition where electric current is used, and finally photochemical decomposition where light energy is used for the decomposition of a substance. What happens in decomposition reaction? One compound breaks down into two or more simpler substances. Right? I hope you understand what is decomposition reaction and what are the different types of decomposition reactions. And now we are moving to other type of reaction, which is displacement reaction. Right? So what is displacement reaction? What exactly happens in a displacement reaction? Right? Here what happens is, here A is more reactive. A is more reactive, so that it will be able to displace B from the compound called BC. Right? So B has been displaced because B is less reactive than A. That is how displacement takes place. Before we take a look at examples, we will take a look at reactivity series of metals. We should understand the reactivity of metals. Right? So here potassium is most reactive, and then sodium, calcium, magnesium, aluminum, zinc, iron, lead, and then hydrogen, copper, silver, and finally gold. Least reactive. These are least reactive metals, silver and gold. Right. Now we will take example for displacement reactions. Let's see here copper sulfate solution. A solution of copper sulfate and iron is taken. So iron nail is dipped in copper sulfate solution. Right? So if this is more reactive than copper, it will displace. Let's now check whether iron is more reactive than copper or not. Okay. Let's refer reactivity series. If you take a look at reactivity series, you will find iron is placed above copper in the reactivity series. So iron is more reactive. So iron can displace copper. Iron can displace copper. So displacement takes place. Okay, so here reactivity of the metal matters here. So now the same thing is depicted here, right? Copper sulfate solution is taken, iron nail is dipped in it, right? So displacement reaction takes place. As a result, there is change in color of the solution and a change in color of the iron nail. So what is this brown color thing? This is copper. Copper has been deposited on iron nail. This copper which has been displaced, it will be deposited on iron nail, right? See now, few more examples of displacement reactions. Silver nitrate solution and copper. Whether copper is more reactive than silver or not? Yes, copper is more reactive than silver. So copper can displace silver. Silver has been displaced. Displacement reaction took place. Now, hydrochloric acid, dilute hydrochloric acid and magnesium. Now we need to check whether magnesium is placed above the hydrogen in the reactivity series or not. Yes, if you take a look at the reactivity series of metals, you will find magnesium is placed above hydrogen. So magnesium can displace hydrogen from hydrochloric acid so that hydrogen gas is liberated. Displacement took place. So it is all about reactivity of metals. A highly reactive metal displaces less reactive metal. So these are single displacement reaction. Right? One element displaces the other element. Single displacement reactions. And now we are learning more about displacement reactions. Let's see halogens. Reactivity of halogens. Fluorine, chlorine, bromine and iodine. Fluorine is more reactive, and then chlorine, and then bromine, and then finally iodine. Fluorine is more reactive. So if you take chlorine gas and potassium iodide solution, see, chlorine is more reactive than iodine. Chlorine is more reactive than iodine. So that chlorine can displace iodine. Chlorine can displace iodine. Displacement took place. You can expect a displacement reaction with non-metals as well. Now we will practice displacement reactions. Right? Which of the following pairs will give displacement reactions? Right? Magnesium chloride solution and iron metal. Compare the reactivity of metals iron and magnesium. Iron is more reactive than magnesium? No, iron is less reactive than magnesium, so it is not possible. Displacement doesn't take place here because iron is less reactive than magnesium, so iron cannot displace magnesium from magnesium chloride solution. Let's take a look at this one. Iron sulfate solution and zinc metal. Zinc is more reactive than iron, so zinc can displace iron from iron sulfate solution, so the reaction is possible. Displacement take place here. This is a displacement reaction. Here, silver metal and hydrochloric acid solution. So here, think about hydrogen here. Silver is placed below hydrogen in the reactivity series. So silver is less reactive than hydrogen. So displacement doesn't take place here. Right? Now we are moving to double displacement reactions, another kind of chemical reaction, double displacement. So here what happens is substances, they exchange their ions. So exchange of ions is involved in double displacement reactions. Let's see. Let's take a look at the general equation. See here, AX plus BY gives AY plus BX. So what did you understand here? See, X and Y, they have been exchanged, they have been interchanged. So basically, ions are exchanged, exchange of ions. exchange of ions. What happens in double displacement reactions? Exchange of ions take place. Alright, so we will now take a look at a few examples so that you understand better. Lead nitrate solution and potassium iodide solution. Two solutions are mixed up. And then what do you notice? These solutions exchange their ions. Okay, so here lead ions and nitrate ions are there. Here potassium ions and iodide ions are there. So they are exchanging their ions. So now iodide ions come and join with lead ions, and nitrate ions go and join with potassium ions, so that we got lead iodide and potassium nitrate. A precipitate is formed. Generally, in double decomposition reactions, precipitate is formed generally, but all the double decomposition reactions do not form precipitate. Okay, so yellow precipitate is formed. Lead iodide gets precipitated. And if you take a look at silver nitrate solution and NaCl solution, if you mix them, silver chloride gets precipitated. Exchange of ions is involved. Silver and nitrate ions, sodium and chloride ions, they get exchanged. And so that we got two new substances, two new compounds. Now, moving to neutralization reaction. So what is neutralization reaction? Acid reacting with base to give salt and water. So basically it is the reaction between hydrogen ions present in the acid and the hydroxide ions present in the base. So that gives water and salt. Neutralization reactions. So they are neutralizing each other. Right? See, let's take a look at the general equation. Acid plus base gives base or alkali, gives salt and water. Right? So generally acid means the H plus ions are present in acid. OH minus ions from base or alkali gives water, and a salt is formed. Right? So here one important thing that we should understand, that neutralization reactions are generally exothermic reactions. Lot of heat energy is released during neutralization of strong acid and strong base. If it is a strong acid and a strong base reaction, then large amount of heat is released. If one of them is weak, energy released will be less. Right? See, strong acid and strong base. Strong acid and strong base reaction. Water and salt are formed. Salt and water are the common products in neutralization reaction. If the reaction is between strong acid and strong base, the amount of energy released is 55.2 kilojoules per mole or 13.7 kilocalories per mole. For each mole of acid and base reaction, we will get this amount of energy is released. This is called heat of neutralization. But if one of these things is not strong, one of these things is weak, then the heat of neutralization will be less than 55.2 kilojoules per mole. So now we are learning something very interesting here about neutralization reaction. See, during indigestion of food, we use a base called magnesium hydroxide. During indigestion of food, we use a base called magnesium hydroxide, which is called as milk of magnesia. Magnesium hydroxide is also called as milk of magnesia. To neutralize the high amount of acid produced in stomach. Right? So the antacid we take, it contains milk of magnesia, which is magnesium hydroxide, to neutralize the more amount of acid produced in stomach during indigestion. Right? And then now we are done with the neutralization reactions, and now we are moving to oxidation reduction reactions. First of all, we'll start with oxidation reaction. What is oxidation? We'll try to understand what is oxidation, and we'll take a look at few examples of oxidation reactions. Right? Oxidation. The definition: addition of oxygen to a substance See, magnesium is there. Reacting with oxygen, magnesium oxide is formed. So, magnesium to magnesium oxide. So, what did we notice here? Addition of oxygen to magnesium. There was no oxygen with magnesium before the reaction, but after the reaction we see oxygen with magnesium. So addition of oxygen is observed. So this is oxidation reaction. And then removal of hydrogen is also oxidation. Removal of hydrogen from a substance is also oxidation. Let's take one example. Removal of hydrogen. Hydrogen sulfide to sulfur, let us see. So what do you notice here? Removal of hydrogen. So this is also oxidation. And now there is a modern concept of oxidation. Loss of one or more electrons. Loss of one or more electrons from a species is also called oxidation according to modern concept, which is also called as electronic concept of oxidation and reduction. Right? So here see a neutral atom called magnesium we have, and it loses 2 electrons so that we get a cation is formed. So what did we notice here? Loss of electrons is noticed here. That means magnesium has been oxidized to magnesium ion. So this is also called as oxidation. So what is oxidation? What did you understand so far about oxidation? Addition of oxygen or removal of hydrogen from a substance or loss of one or more electrons from any species. This is oxidation. And now we are moving to next type of reaction, reduction reaction. So what is reduction? Addition of hydrogen to a substance is reduction. Let's see. Bromine to hydrogen bromide, let us see. What do you notice here? Addition of hydrogen is noticed here. So this is, according to definition, this is reduction. Bromine to hydrogen bromide, it is reduction. So bromine got reduced to hydrogen bromide. We say bromine got reduced to hydrogen bromide. Right? Next, removal of oxygen is also considered to be reduction reaction. Removal of oxygen. Let us see copper oxide to copper. Let us consider this one. Copper oxide. Oxygen has been removed from copper oxide so that we got copper metal. So what happened here? Copper oxide got reduced to copper. Copper oxide is reduced to copper metal. So here what did we notice here? Removal of oxygen. Removal of oxygen. So this is reduction. According to modern concept, electronic concept, gain of electrons is reduction. Gain of electrons is reduction. So let us see chlorine, atom of chlorine taking an electron, giving us chloride ion. It is gaining 1 electron so that we get an anion is formed. Right? So here we notice gain of electrons. So this is also a reduction reaction. So what is reduction? Basically, either addition of hydrogen or removal of oxygen from a substance or gain of 1 or more electrons. This is reduction. And finally now we are moving to redox reactions. Very interesting. What is redox reaction? A reaction in which both oxidation and reduction takes place simultaneously. Very interesting. Oxidation and reduction takes place simultaneously. Right? So here let us take an example. Right? So zinc oxide reacting with carbon to give zinc and carbon monoxide. So let us see which substance will undergo oxidation, which substance is undergoing reduction. Why do we say this is a redox reaction? Let us now try to understand. Right? Let's take a look at zinc oxide. Zinc oxide has been reduced to zinc. Why do I mention it is reduced? Because here we notice loss of oxygen. Loss of oxygen. According to the definition, loss of oxygen, it is reduction. According to definition, loss of oxygen means reduction reaction. So we say zinc oxide is reduced to zinc, right? And so here one more important thing, reducing agent and oxidizing agent. So zinc oxide got reduced. So who helped zinc oxide to undergo reduction? Carbon. How? By taking oxygen. Carbon, by removing oxygen from zinc oxide, it is helping zinc oxide to undergo reduction. So carbon is reducing agent. Reducing agent. So who is reducing agent here? Carbon is reducing agent. Simple. Right? And one more important thing, reducing agent always undergo oxidation. Reducing agent always undergo oxidation in any redox reaction. So let us see how. This is reducing agent. Let us see what happened to carbon. See, carbon to carbon monoxide. What do you notice here? Addition of oxygen. Addition of oxygen. Addition of oxygen. So according to definition, addition of oxygen is oxidation. Oxidation. So what do we say? Carbon is oxidized to carbon monoxide. I told you, reducing agent always undergo oxidation. Yes or no? Right. In the same way, now who is helping carbon to undergo oxidation? Zinc oxide. How? By providing oxygen to carbon. It is providing, it is giving oxygen to carbon. So zinc oxide is our oxidizing agent in this redox reaction. So now we are able to find the substance which is undergoing oxidation and the substance which is undergoing reduction, and oxidizing agent and reducing agent. What is the substance oxidized here? Substance oxidized, carbon. Substance oxidized is carbon. See, carbon undergoes oxidation. And substance reduced, zinc oxide is the substance which got reduced to zinc. Right? Hope you understood what is oxidation, what is reduction, and then oxidizing agent and reducing agent. Hope it is clear to you. Right? Now we are moving to effects of oxidation reactions in everyday life. So oxidation reactions have got damaging effect on food and metals mainly. Right? If oxidation reaction has a damaging effect on metals, then we say corrosion. So oxidation of food, we say rancidity. Right? We will now discuss them one by one. So damaging effect on metals, it is corrosion. We call it corrosion of metals. So what is corrosion? Corrosion means gradual eating up of metal when the metal is exposed to atmospheric air. Right? So here what happens is metal loses its shiny appearance on oxidation. Right? Let's take a look at few examples. Let's take a look at iron metal. When iron is exposed to atmospheric air, it reacts with oxygen and moisture present in the air. And then what happens is on the surface of iron metal, a reddish brown colored substance is formed, which is a new substance. A reddish brown colored substance is formed. You might have noticed it. Right? So what is the reddish brown colored substance coated on the surface of iron object, which is hydrated iron 3 oxide, right? And which is in reddish brown color. We also call it rust. We also call it rust. Corrosion of iron, we also call it rusting of iron. Right? And then if you take a look at silver metal, the effect of oxidation on silver metal, we will take silver, and when it is exposed to atmospheric air, it reacts with hydrogen sulfide present in the atmospheric air, and then it loses its shiny appearance, and then it will turn into black color. Right? What is the new substance formed on the surface of silver on oxidation? which is silver sulfide, and hydrogen gas is also liberated. So, effect of oxidation on metals, we call it corrosion, right? And then we will take a look at the effect of oxidation on food items containing oil and fats. So, what will be the effect of oxidation on food items? Now we will see. Yes, we call it rancidity of food. When any food item containing oil or fat is exposed to atmospheric air, it will undergo oxidation and you will observe change in smell and taste. This is called rancidity of food. This is also one of the effects of oxidation, right? And now the thing is, how to prevent rancidity? Prevention of rancidity by adding antioxidants to food items like nitrogen gas, which is inert. It doesn't react with food item, so it is packed. The food items containing oil and fat are packed with nitrogen gas, and then keeping food in refrigerator. We can prevent rancidity by keeping the food items in refrigerator and storing the food in airtight containers, and then keeping the food away from light, right? We are done with the topics, all the topics. We have covered all the topics from this chapter, and now we are trying to check ourselves how far we understood all these topics, okay, taking an exercise, right? The exercise is here. What we need to do is, what type of chemical reactions are represented by the following equations. Some equations are given here. What we need to do is, we need to find what type of reactions they are representing. Okay, we will consider one by one. This one, if you take a look at this one, A plus BC gives AC plus B. So here, what do you notice here? See, there is a compound called BC here. From BC, A is displacing BC. B has been displaced. So we can easily find it out that A is more reactive element than B. So that A displaced B. That means it is single displacement reaction. It is single displacement. What happens in single displacement reactions? We have learnt, right? What happens in single displacement reactions? A highly reactive element displaces less reactive element. That can be a metal or non-metal. Simple, right? Next one. A plus B gives C. Very simple to understand this one. Two substances combining together to give a new substance, a single substance. So what kind of reaction is this? This is combination reaction. We know in combination reaction, a single substance is formed. Two or more substances coming together to give a single new substance in combination reactions, right? Next, X gives Y plus Z. Very simple again, right? One substance breaks down into two or more substances. What kind of reaction is this? Decomposition reaction, right? One substance breaks down into two or more substances. See, one substance X breaks down and giving two new substances Y and Z. So this is decomposition. Right? Next one. This one. Let's take a look at this equation and let's try and find what kind of reaction it is representing. PQ plus RS gives PS plus RQ. So what do we notice here? See, PQ, PS, RS, RQ. So what do you notice here? Exchange of ions. We notice exchange of ions. See, Q and S have been exchanged. Right? So that we get two new substances called PS and RQ. So here, what did we notice here? Exchange of ions. Then what do we call them? Where do we find exchange of ions? In what kind of reactions we find exchange of ions between two substances? Double displacement reactions. So this is double displacement reaction because exchange of ions is involved here, right? And then take a look at this one, very interesting again. See, A2O3 plus 2B gives B2O3 plus 2A. So what do you notice here? What do you notice here? See, A has been displaced here. Who displaced A? B. B is displacing A. B is more reactive. So we should understand that B is more reactive than A, so that B is displacing A. It has been displaced. Right? So it is also a single displacement reaction. Single displacement reaction. Right? And finally, this one, very interesting. X gives rise to X2 plus. So we need to apply electronic concept here. Electronic concept of oxidation and reduction. Let's take a look at electronic concept of oxidation and reduction. So loss of electrons is oxidation, gain of electrons is reduction. So here what happened here? X been converted into X2 plus. So what do you notice here? Loss of electrons. Loss of 2 electrons here. So X losing 2 electrons to give X2 plus. So loss of electrons means it is oxidation. Loss of electrons means, according to modern concept, loss of electrons means oxidation. So this is oxidation reaction. Right? I hope you are very much comfortable with all the types of chemical reactions, right? So now, what did we learn so far actually in this session? Starting with chemical reactions. What is chemical reaction and the characteristics of chemical reactions? And then we have been moved to chemical equations. What is a chemical equation? And then essentials of chemical equation. And finally, balancing a chemical equation and making chemical equation more informative. And then finally, we learnt types of chemical reactions, combination reactions, decomposition, in fact various types of decomposition, thermal decomposition, electrolytic decomposition, photochemical decomposition, right? And then displacement, single displacement and double displacement, oxidation and reduction reactions, redox reactions, where we learned what is oxidation, what is reduction, and what is oxidizing agent and what is reducing agent. Okay, we have learnt more and more, right? And then finally we have learnt effects of oxidation in everyday life. Okay, effect of oxidation on metals, we say it is corrosion. Effect of oxidation on food items, we say rancidity. So how to prevent rancidity we have learnt, right? So we have covered each and every topic from this chapter, and I hope you are more comfortable with this chapter now, and you will be able to solve any kind of question from this chapter of any level, whether it is board level or Olympiad level or NTSC level. I'm sure you will be solving very comfortably, right? Thank you.